Hello, we are back with some complex Sudoku. I took a little bit of time off the channel because, frankly, I forgot about it. I go in and out with the whole Sudoku thing. This channel is not meant to be very, very frequent with puzzles. It's just my outlet for interacting with Sudoku, you know? Anyway, we have an interesting one here today. Eye of Agamotto by Allagem. Some pretty simple rules, but my first time with one of them. So, let's go over it. First of all, normal Sudoku rules apply. That means the digits 1 through 9 must appear once each in every row, column, and 3x3 box. Adjacent digits on a green line must differ by at least 5. That's German whispers. So that means if this were to be a 4, then the next one on the line has to be at least 5 away. That means this would have to be 9. And then this is where the 159 rule comes in, which I've never done myself, although I think it's somewhat popular. So digits in columns 1, 5, and 9 index the column locations of digits 1, 5, and 9 respectively in each row. And the example that they give is that if row 2, column 1 is a 4, then that means row 2, column 4 is a 1. And so I think what this is saying is, let's use another example. If this were 8, then that means that the number 1 is in the 8th column of this row. So that would be here. So this column indicates where the 1 is, this column indicates where the 5 is, and this column indicates where the 9 is. If we were to go on the reverse here, if this were 3, then this would be 9. So that's that rule. Hopefully I got it right. If I didn't get it right, I'm going to have to re-record this. Link is in the description if you want to give it a shot yourself. Now I'm going to take a stab at it. So usually, well, okay, I'm not entirely sure if there are any, like, go-to tricks with the 159. I was thinking about, like, oh, what about the 1 in column 1? But really, this is just pointing to itself if this is where the 1 goes. So there's not really anything weird happening there. And I suppose you can have, like, a 1 and a 9 like this. Or I guess the inverse as well, right? This is saying that the 9 is in the 9th column, and this is saying that the 1 is in the... Oh, no. Oh, okay, wait a second. What is this saying? Oh, yeah, this is saying that the 9 is here. Yeah, okay. So this is allowed. Okay. Yeah, okay. So there is one rule about German whispers that I always go to and I always know, which is a German whispers cannot have a 5 on it. Because if the 5 is here, you can't go 5 away on either side of 5. So 5 cannot be there. That means that 5 in this row has to be somewhere here, and 5 in this row has to be somewhere here. And, I mean, I guess we could do the same thing with these columns, but I don't want to look at that just quite yet. And what's interesting about this to me is these two spots now. Because I think what this means is, because this 5 is in columns 1, 2, or 3, then the index has to be 1, 2, or 3. And then same thing here. This would have to be 7, 8, or 9. Which is like, this is not particularly revolutionary because this can only be 6, 7, 8, or 9 anyway. But what it does do is it tells us the highs and the lows pattern of this line. So we know that this is a high number, and then it's going to go to a low number, 1, 2, 3, or 4. And so therefore, this one and this one also have to be high numbers. And usually I would use coloring for this. Can I get away with that? Yeah, I think I can get away with remembering how this rule works if we overwrite the coloring here. So let's just do that, and then these would be blue, or low. And then it's the same thing here. I don't know that coloring is particularly going to help us in this puzzle, but I don't know, it's worth thinking about. Oh, okay, so then yeah, what this is telling us, I think... Oh no, this isn't telling us anything. I was gonna say that this now, you know, where does the 1 go in row 9? I was gonna say it has to be one of these 3, but it actually doesn't, because 1 could go into... actually any one of these 3 spots. All we know is that these 3 numbers are a 5, a high, and a low. That's all we know. Okay, there is another thing that we know, which is that this can't be 6, because then you would need to have 1 on both sides of this 6. So this has to be 7, 8, 9 as well. This could be 6, though. And then I guess it's the same point on these 2 blues as well, right? These can't be 4. These have to be 1, 2, and 3. And then I think we can apply the same logic down here. Yeah, it's the same logic. Oh, that's cool. Oh, and it's probably the same thing down here. Okay, here's something I've seen. So, whatever's in this spot is telling you where the 1 is, right? That means that that number is either 2, because it would be in this spot, 4, 6, or 7, 8, 9. And the thing is, it cannot be 2 or 4, because we know this is a high number. This is 6 or higher. So, in fact, we already knew that this was 6, 7, 8, 9, but what it tells us is that these are not 1. These are 2, 3. That's pretty cool. And now we have a 2-3 pair, which means this is a 1-4. Okay, we're getting somewhere. That is really interesting. Now, can this be 9? That puts 1 here. Yeah, that's the scenario we practiced at the very beginning of this. Oh, no. This can't be 9. Because if this is 9, this is what? No, it can't be. Don't be stupid. It's my first time with this rule set. I apologize. I have to wrap my head around it a little bit. Okay, now I think we can do the same thing down here, right? Because this is saying that this low number has 9 somewhere. And that means it has to be 1 or 4, actually. Oh, yeah. Oh, it's the same. Wait a second. Is it the same thing here? No, because 1 can be anywhere here. And in this spot, this is a low number telling you where 9 is. So 1, 2, 3, or 4. But in this case, we know it's 2 or 4, telling you where the 9 is. That means 9 has to be in one of these 2 spots. Okay, that's... oh, no. I got my numbers wrong here. This is 1 or 3. Oh, no. Wait a second. I'm getting it all backwards. See? This is messing with my brain a little bit. This is telling you where the 9 is, in which column. And we know it can't be... okay, this is right. This is more similar to the logic up here. It can't be 6, which is this is column 6. This is column 8. It can't be 6 or 8. It has to be 1, 2, 3, or 4. So again, we already knew this is 1, 2, 3, or 4, but we know these can't be 9. That's the logic. Which means this has to be 6 or 9. So 9 is somewhere here. 5 is, or 1 is somewhere here. Okay. All right. Okay, so now I'm feeling like I'm reaching the limit on these, I think. Oh, I guess this can't be 3, because you would have to have 8 on both sides. So this is 1 or 2. This can have 8, 9 on both sides and still be 3. And this can't be 4, because this would have to be 9. Never mind, I was not reaching my limit. This is telling us that 4 has to be somewhere here, because 4 is not here. So it's like 4, 5, and then 6, 9 to pair up with this one. Kind of interesting. Now, we know this can't be 4, because otherwise 1 would have to go there. We can take that away. So, okay, I think actually what we can do, we can actually just type all these numbers in as primes here. So 4, 5, 6, and 9, right, are our options. We know that this is not 4. It can be 5, but it can't be 6. This cannot be a 1. But 9 can be a 1, and 5 can be a 1. Okay, so that scenario that we were playing out at the beginning about, oh, can this be 9 and 1, is actually playing out in this row. Because this is either 5 and 1 here or 9 and 1 here. Oh, which means 1 can't be here? That is what that means, yeah. Right? This cannot be column 7, because we know that 7 is in one of those 2 spots. Yeah, so this is a 2. Holy cow. We got a number, folks. So now we have 1 3s here. So this is saying we have 5 in either column 1 or column 3, so it's not here. And this is saying we have 9 in column 1 or column 3, so it's not here. This is a 4, 6. Now, does that mean this column 3 needs to be a 5, 9? If this is 1, that's 5. This is 3, that's 9. And then, yeah. So this cannot, there's no scenario in which this can be 4 or 6, because these columns are saying, like, 3 has to be on one of these 2, which means that 3 is either 5 or 9. Okay. Now we have a 5, 9 pair here. That means this is a 6. Okay, we're getting numbers. Now, we have to be able to do the exact same logic up here, right? I don't remember how I started this. This can't be 6 because this would have to be 4. Oops, or not 4. This would have to be 1. Oh, shoot, I forget how I started this whole process. I'm gonna undo just to see what my first step was on this. Yeah, okay. I figured out that this couldn't be 7 because that's 4 away from 3, which is the highest number that it's surrounded by. Okay, I did a bunch of rewinding and I could not figure out how the heck I got to this conclusion, but I remember looking at the 1, 5, 9 column, so let's just try that. So that means 1 has to be on 7, 8, or 9. Okay, right. This is saying 1 has to be somewhere here, which means this can't be 1, this has to be 4. And then that makes these numbers 1, 5, and then a high number. Yeah, this also, yeah, both of these have to be 7, 8, 9, because we know that 1 and 5 are down here. Oh, okay, and then what is this possibility here? 9 is going to appear on either column 1, 3, or 5. So that's what this is. But we know it can't be 3 because, hold on, I'm going to take out these markings for a second. We know it can't be 3 because number 9 cannot go into, oh, wait a second, 1, 3, or 5. Yeah, we know it can't be 3 because we have a 2, 3 pair here. So that means this is not 9, this is 8. There we go. That's how we solve this. So this is 1, 5. I think this whole row is 1, 5, 6 now. Is that right? Yeah. And we know that this can't be 6. Although somehow I got 3 digits down here and I only have 2 digits up here. Oh, the 5 can only be 7 or 9, so this can't be 5. Oh, and 1 is in either column 7 or 9, not in column 8, so this is 6. That's how we got the 3 digits. There we go. Now we're roughly equal on both sides. I feel like that took me a really long time to actually get to this point and to, like, remember how I did the bottom bit, but whatever. We got there eventually. I guess we can color these as well now. Again, I don't know if the coloring's actually going to help us, but... Okay, let's see if we get any other insights here. Oh, you absolute fool. Yeah, just look at the dang German whispers here. This is a 4, therefore this has to be 9. It's solving for us. This is 7, therefore this is 1 and 5. And then I assume we can do the same thing down here. This is 6, so this has to be 1, which means 5 is on here, and that resolves the rest as well. Okay, cool. We got a bunch of numbers. 7 minus 5 is 2, so that has to be 2. And 3 plus 5 is 8, so that has to be 8. Okay, we got 2 whole rows. Look at us. Nice. Honestly, just pause for a second. That is so cool that can actually be, like, such simple rules just puts in 2 rows immediately. I don't know. That's really cool to me. Now, where do we go next? I don't feel good, Mr. Stark. I feel like these lines are very interesting to me. I have a feeling they interact with each other in some way. The thing is, like, it's not... If 9 is here, that means 1 is here. That's actually totally fine because those are the most flexible numbers on a German Whispers. That doesn't really freak me out. And we also know there's going to be like 2 highs and 2 lows on each of those, but we don't know the positions of those. Oh, okay. Is there something here like, okay, this cell is going to tell us where the 5 is in this row, but it can't be 7, 8, or 9 because there's already a 5 there. So this is technically 1 through 6. And then even then it's technically 1, 2, 5, 6. Is that like a thing? Is it the same thing here? Are these both 1, 2, 5, and 6? I'm not typing this in, but I just want to make sure that that's... Oh, okay. Yeah, and it can't be 1. So these can't be 1. These can't be 7, 8, 9. And these can't be 3, 4. Right. So... And then this can't be 5. Okay, we actually did get somewhere there. Oh, and this can't be 6, because then both of the... Actually, that would be fine. Both of those can be 1, right? Can they be? Yeah, both of those can be 1, yeah. Okay, I have a feeling this is the right idea. Let's do the same thing down here. 5 down here cannot be 1, 2, or 3 because of this. That means it's 4 through 9. And if we just type all those in, we'll see that they can't be 6, 7, or 9. Hello? Oh, I think my computer broke. What the heck? There we go. Okay. And then this one can't be 5 again. Now, what's crazy is that, like, we can't just put a 5 here, because 5 can still technically... Like, this could be a 4-8 pair, for all we care. And again, this can be 4 because both of these can be 9. Yeah. Oh, is it this? I think, oh, it could be this. Yeah, this is very interesting. Okay. So what can this be? It's gonna, this cell determines where 1 goes in the row. Well, it can't be 7, 8, 9 because of that 1. It can't be 5 because of that 1. And we know that that's not 1. So hold on. It's 1, 2, 3, 4, and 6 are the options. And then it can't be 2 because of that 2. Okay, that doesn't seem as promising as I hoping. If this is 4, this has to be 9, which means this has to be 1. That's totally fine. Okay. You know, I thought that the little green line sticking out here was going to be the savior, but yeah, and then the same thing on this side. It's just not 1, 2, or 3 because of this 9. It's not 5 or 8 because that whole block is seeing those 2 numbers, and it's not 5. Not going there. Yeah, so we're just ended up with 4 numbers in these spots. Not tremendous. Okay, I just found something super random. I was literally just, I don't know how, maybe I have to talk this out to make sure this is actually right. Okay, I was looking at, like, where does 7 go in this column, right? Like, where's 5 going in this column? And we know that 7 is not these 2 or these 2 or these 2. That means 7 has to go somewhere in here. And 7 cannot be these ones because 5 cannot go here. So that means 7 has to go here. I just got a digit randomly on this one, which means 5 has to be here. That's super, that kind of came out of nowhere. I was not expecting to just get that. So maybe there's some more exploring I have to do there. Like, is it the same thing on this side? Where does 3 go in this column? We know it's not these, we know it's not this one, and we know it can't be this one, so this has to be 3. Okay, super interesting. Yes, that's so cool. And then therefore, this is 5. Wow, okay, that was just totally out of nowhere. I don't know if that's what I was supposed to find. Is there more of that? Oh, yeah. So, like, where does 9 go in this column? No, that's not right. Okay, well, let's just look at this middle digit then. This is 2, 4, 5, 6, and 8. Now, 5 cannot go here, so this can't be 2. And 8, Yeah, I can't go there. No, 8 is here. Yeah, I can't go there. So this is 4, 5, or 6. 5 is going either here, here, or here. Oh, yeah, that's right. Okay. Now we know 7 is in one of these two spots, and 3 is in one of these two spots. 5 is in one of these 3 spots. Oh, okay, and 5 is in one of these 2 spots because of Sudoku. We're getting a lot of Sudoku stuff here. Same thing here. Oh, yeah. Okay, I'm back at these lines. So we know that these can't be 1, 2, or 3 because of this box. And we know that, like, 1 has to go somewhere in this box. And 1 can't also go here because it's being seen here. So, 1 has to be somewhere in these 2 spots. And then I think it's the same thing with 9 over here. Yeah, 9 can't go here. 9 can't go here because the 1 is over here. So, yeah, this is a 9. Does that mean this has to be a 5-9 pair and a 1-5 pair? Is that how that works in Sudoku? I think so, right? If this is a 9, that means 5 has to go here. And if this is a 5, that means 9 has to go here. Yeah. This is just a 5-9 pair now. That means we have a 5 and a 9 in this box and a 5 and a 1 in this box. I think that's going to change things, isn't it? Does it? Yeah, I guess these can't be 7, 8, or 9 now. Oh, and these can't be... Oh. No, one of these has to be 8. If one of these has to be 5, then one of these has to be 8. Oh, right. And then one of these has to be 8 as well. So we have an X-wing of 8s here. And then it's the same thing here. This is, one of these is 2, and one of these is 2. Holy cow, this is getting a little wild. I mean, I guess we already knew this 2 and 8 info, but I think these are the new ones here. Okay, so on this line now, the 2 high numbers are 6 and 9. That means 6 has to be on one of those 2 spots, right? I think that's right. And if 6 is on one of those 2 spots, that means 1 is in one of those 2 spots, which I'm not going to pencil in. But it also means that 1 is in one of those 2 spots. It means this can't be 1, because the 6 has to go to a 1. And it's either going like this or like this. And of course, that 1 is referencing itself. Right, and then if this is a 6 and this is a 1, then this has to be a 9. Okay, let's just delete everything here for a second. It's either this is the 6 or this is the 6, which means this is the 1 or this is the 1. And if this is 6 and 1, this has to be 9, because we know 7 and 8 are not in the picture. Therefore, it could also be 6, 1, 9 this way. Booyaka, booyaka. And if this is 6, 1, 9, then what is this? Any number? 1, 2, 3, or 4? It can't be 1, 2, 3, or 4. Can't be a 2. Yeah, this is 3 or 4. Both sides here. Hello. That tell us something? This can't be 3. So if this is 6, 1, 9 in this direction, this has to be a 4 rather than a 3. Or a 2 or a 1. Why can't this be 2? This can be a 2. Okay, I screwed something up there. I'm going to do this one more time, but I won't. I'll just tell you the end result of this whole experiment here. Okay, here's the end result here. So we know that 1 and 9 are here, which means that 1 is in one of those spots, right? Well, does that mean this is also a 1-9 pair? No. It just means that 1 is in one of those spots. Yeah. Wait, if this is a 9, this is a 1. Yeah. Right. Just references itself. Yeah. Okay, so we figured all this out by knowing that 8s are here, 7s are here, which means the 2 high numbers here were 6 and 9, and 6 had to be on the end. Can we do the same thing over here? Because this is a very symmetrical puzzle. We know that, we knew that this line couldn't have 2 or 3, which means the low numbers are 1 and 4. That means 4 has to be on either side of this. Oh, and look, we know that 1 has to be in one of those 2 spots. And if 4 is here, this can't be 1. That means 4 has to go here, right? Let me just double check this. 1, 2, and 3 are accounted for, which means and there has to be 2 low numbers on this Renban. So we have the 1s in one of those spots, and the 4, yeah, it has to go here. 4 can't go here and have 9 on both sides. This is a 4, and this is a 9. Okay, well, that's going to open some things up, and I hope that I haven't just broken the whole puzzle, you know? I hope I have not just broken the whole puzzle. Let's see. Okay, now if this is 4... that means this is 9. And then look at the 9s in the bottom boxes. It has to be somewhere here. Can't be here. Can't be here. So this is 9. Oh, we know that 1 is in one of these 2 spots, but it couldn't be here because this is the low number. So this is 1. It means this is 9 and 1. It means this is not 6. This is not 3 and 4. So this is 6. Yeah, this is really unraveling and it scares me. Usually when it unravels like this, everything has gone wrong. But if we trust our markings, then that has to be 2. And then we have a bunch of numbers to fill in here. This becomes 9 and 5. This, yeah, okay. Okay, that lined up at least. This is 5. Column 6 is not number 1, 2, or 4. So one of those two is 1. I don't see any problems with that. Oh, this can't be 1. Yeah, so this has to be 4. Oh, and we know that... no, we didn't know anything, actually. This is 4 and 1. Okay, let me just get my coloring all correct here. I won't lie, I'm going to be very surprised if I haven't broken this, just because of how smoothly this is going. But if I haven't broken this, then my god, what a great job by the puzzle setter. This has to be a high number. 6, 7, or 8. Can't be 7, so this is 6 or 8. And then that means 9 is either here or here, and it can't be here, so that means this has to be 9. 6. Okay, let's look at our green red bands in the middle now. We know these colors, which makes this 7, 8, or 9. We know it can't be 9. This is 6, 7, 8, or 9, this one. And it can't be 8, 9. 1, 2, or 3 down here. Can't be 1. 7, 8, or 9 here. Can't be 9. We're definitely getting somewhere. Have we gotten every single 159 column thing going on here? I better check that. I think I have. Ah, 5 has to go here. Okay, I mean, it's almost done, right? It's a little scary. I think this is a 2-3 pair here. Yeah. So 3 and 1, and then 2 and 1. Okay. Things aren't broken. 3. This has to be 8 then. Oh, what's left in this box? 4. What's left in this column? 7 and 8. Okay, this has to be 7 and 8. And therefore... Oh, yeah, we already knew that, actually, because of this. But that means this is 9. This is 7. I think that this is working, and that kind of blows my mind. This is 2 or 3. This has to be 6 now. This is 7, which forces this. Now we have a 4, 5 pair in this column, which means this has to be 6. And therefore, this is 5. One number left with 8. Holy cow. I'm solving it. This is a 4, 7 pair up here. Oh, which means this is a 3. So we've almost filled every column, 159 column, except for these two, which is totally fine. So that means we should have every single one. Oh, I can't even highlight them. That's okay, I'll eyeball it. Yeah, we have every single 1 and every single 9. Yep, okay, great. And most 5s. These are 2, 4, 5. Okay, fantastic. And that leaves these to be 3 and 6. That solves this Renban. Or, oh, I've been calling them Renbans this whole time, I think. If I've been saying Renban, I mean German Whisper. We know this is a low number that's not 1 or 3 or 2, so this must be 4. Ah, okay, that solves these. Oh, that's it, folks. We're coming up to the end. These are 2, 3, and 7. These are 3, 7, and 8. 8, 7, 3 there. That resolves this side. And we have 1 box left. Probably a faster way of doing this, but I'm just going to type them all in. 2, 4, 6, and 8. That should just fill it in for us. Yep. Hey, you solved the puzzle and the solution is correct. You can see it took me over an hour to get that one. My monkey brain is still in prime effect. Although I just watched the Planet of the Apes and now saying monkey brain is like I've been saying that in every video. But now I'm like, those monkeys got some good brains. They just needed a genetically altered virus to make it have... I'm going off the rails. Folks, thank you for watching if you did watch. That was a lot of fun. Awesome. Huge shout out to the puzzle setter here. It like flowed like butter to the point that I thought I was breaking it and I didn't break it. So I'm very happy about that. Hey, until next time, farewell.